Okay, so keynote here. Well, somebody tell me to shut up if I start going over. Sometimes I get into this computer science stuff. It's fun. All right. So last time we were just kind of reviewing, getting ourselves kind of caught back up to get us jumping off the uh, um, new material we're going to be walking into. We talked about reminding ourselves the difference between primitive types and object types and why we have different size things for holding different size values. We talked about kind of the idea of a memory address, pointers, kind of different ways of representing these numbers and why we might do it. So like we kind of ended on something like this where we talked about, here's three values right here, and all three values mean the same thing, right? It's like English, Spanish, German, if you want to think about it that way. We're just representing a value, a unique value in three different languages. How we then use those values is kind of up to us as the computer scientists to decide, are we using these for doing mathy stuff? Are we using these just to uniquely represent states like we do with the ASCII or the Unicode table? Which then tells us why the char primitive type doesn't store negative numbers, because the ASCII and the Unicode table are just 0 to some number, not negative some number to negative some number. We're just using it to keep track of states. Right at the end of class, we were being reminded about the kind of why hexadecimal and octal have become popular. Octal is always the one that's more obscure. Hexadecimal kind of has, you know, it's more widely used outside of computer science, just in random places. You maybe have seen hexadecimal numbers before. So, almost accidentally, kind of in a lot of those hash values, like if you get a password or something like that, it gives you the hash version of it. It's usually in hexadecimal. Um, but in any case, the rationale of why they use base 8 octal and base 16 along with binary along with decimal is depending on the various people involved in the problem solving. The decimal is because of us. We're talking to computers. We like 10 fingers, 10 toes. We do base 10. Binaries because of the computer. On off, 0 1, digital stuff. Okay. So what about the two things in the middle? I think last class I had asked the question, why do we typically represent memory addresses as hexadecimal values? And I think Nathaniel said that, well, lots and lots and lots of memory addresses. So if you were going to index all of them, you'd end up having some gigantic number, especially if you wrote it in binary and really wanted to make it look scary. So what does hexadecimal do? It lets us have a tighter footprint for the same value, i.e. BAD instead of all those ones and zeros. It's a compressed way of storing that, of representing that same value. So that's why a number system like hex, something larger than base 10, the larger the number system, we might say the better. But why did they stop at base 16? Why did they just say, oh, well, why don't we'll just use base 20? Then we can even make it shrink a little bit more, or base 24. So why did they choose base 16? With the punchline being what would be the next base they would choose. If we decide that we get so much RAM on our computers that we no longer can represent the individual buckets of memory inside of 2 to the 64th power unique places, and now we need more, which means our number of memory addresses gets way bigger, larger than hexadecimal can let's say represent within a certain bit space. 64 bits for most of our modern operating systems. What would be the next base we jump up to? It's not base 17. It's not base 18. What is it? Base 32. Why? It is because if you multiply by 2, it goes to the next power 2, but then that then directly relates to how its relationship with binary, moving between those representative states. So moving between binary and base 16 is easy because you can represent every single one of the hexadecimal digits, the hextets, which is 0 through 9, A through F. You can represent that in its entirety in 4 bits. So there's exactly that many uh, spots with no wasted space. If you wanted to go up to the next biggest value that you can still store, but still have that convenience of being able to move back and forth between binary and that base, you'd have to move up to base 32, which now can represent the entire bit space of all the base 32 digits in 5 bits in its entirety. 0, 0, 0, 0, 0, and then 1, 1, 1, 1. 1. All right, better at computer science and counting. It's a it's a curse. All right, so that's the rationale there. Octal is for the same rationale, but it's just kind of more obscure, like why octal. We use it in computers pretty often. If I open up a terminal here real quick, and I do, uh, and I it's just my downloads folder over in the far left. It shows me the permissions. This is the user. The first 3 are permissions for user, read, write, or execute. The next one is for the group that my account is in, read, write, execute. The last one is for the system owner, read, write, execute. This is done through a command called change mode, and you can change mode like 755 some file. That's an octal value. The allowed octets for an octal number is 0 through 7. So it's usually 0 to the base minus 1. So that's a use on a computer of where octal is actually used, because for read, write, and execute, they've just broken it down into the states can be represented with octal values: 755, 777, 733, that type of stuff. More obscure, probably not something you're going to bump into real often, but the rationale is octal can be represented fully in 3 bits. The full octet, 0000 to 1111. 1111 is 7. 0000 is 0. Covers all of 0 through 7. And they would have just decided that, well, we didn't use base 4, because that only gives you 0, 1, 2, and 3. And that didn't maybe let us represent enough unique states to be useful. So hence octal. All right. So let's see, it gets us up to number bases. All right, so then kind of lastly, just to get us right back to where we were, we have the idea of objects. How do objects differentiate themselves from primitive types? We talked about what primitive types were last class, right? Things built into the language. They can only hold a value. There's some details under the hood about the size of the values that they can hold. But from our perspective as modern programmers, we don't get too hung up on that, right? We need to hold a whole signed integer. We put it in an int. We don't think about too much how much space we might be wasting. We only bump it up to a long value we were trying to hold didn't fit. And the compiler will yell at us about it. It's going to say this number's too big. So you just change int to long and you move on. But so how do objects differentiate themselves from primitive types? Okay, so right off the bat, they could do stuff, right? They got methods. So objects can, for instance, we're dealing with like strings. Strings can report their length. Strings can convert themselves to uppercase, to lowercase, to give you the character at a certain position, things like that. They have all these abilities that primitive types do not have. An int can only hold a value. A char can only hold a value. All right. So right off the bat, objects differentiate themselves that way. What else? What are the 3 components that all objects have? If you're writing your own object, all objects are made up of a collection of 0 or more what?
Constructors. One more.
F starts with F.
Fields.
So we have fields, we have methods, we have constructors. So fields these are our variables owned by the object. Methods, these are the abilities that the object can perform. What about constructors? What's the role of a constructor? Good. So they construct the object. Constructors are involved at the very beginning when you're bringing that an instance of that object into existence. The job of a constructor is to kind of initialize the starting state of that object. So like she mentioned, it kind of gives the values to the fields is a pretty common use of a constructor. You don't have to give values to all your fields if it doesn't make sense, but that constructor is your opportunity to give yourself that default value for your object before it just goes out into the wild and the users start working with it. All right, so constructors, special kind of method called once when the object is first created and typically sets up the initial state of the object in terms of values for the fields, throw an etc. on there. You might do other stuff in there too, but it's your opportunity before you release it into the wild for the user to get it set up ready for the user to work with. Kind of like a toy coming with like batteries already installed type thing. All right, so throwing another question out there. Why do methods have return types, but constructors don't? So we look at the idea of defining a method has return type, method name, parameters, where a constructor has constructor name followed by parameters. Why do constructors not have a return type? That's what I'm asking there. It's the rationale. Good. Okay, what's the purpose of a return type? Well, perhaps the user who calls a method. So for instance, if we looked at the length method inside of string, the length method inside of the string class would have a return type of int. It's going to be called length, and it takes no parameters. So you might have something like string s is equal to hello, and then you might say s dot length. So this return type advertises the kind of value that calling that method will result in, boil down to. It doesn't do any dictation of how we have to use that value. I can just say s dot length out in the wild there, and that was a waste of time. It'll return the number 5 that I'm not using. Instead, I could do something like, int a is equal to s dot length, and I can store that number 5 inside of a variable and use it. Okay, but the return type for a method indicates the kind of value it will send out. It will return to the user for the user to do whatever they want, including nothing with. All right, makes some sense? So that's what a return type does. Java and C#, most of our modern languages enforce return types. That is to say, if we specify that we're going to have an integer as a return type, and then when we write that method ourselves, we do not return something, it will yell at us saying, hey, you told me you were going to return something, you didn't. Either don't tell me you're going to return something and set the return type to void, that you're going to return nothing, or return something, buddy. All right. So that's what return types are there for, to send information back to whoever called upon that method. So why don't constructors have a return type? Good. Yeah. So he's got it. So constructors are always called with a new keyword, except for the when you're building strings because Java gives you shortcuts. Because typically in Java, you can say string s is equal to hello, which is legal. That's the only object that you could take a shortcut like that with. But you could also say string s is equal to new string hello. That's calling upon the constructor. We see it visually calling upon the constructor there. And constructor calls always get called after the new keyword. And what does the new keyword do for us? Go ahead. In this case, it creates a new instance of the object, but if we're just talking about the new keyword, what's the job of the new keyword? I refer to it as our real estate agent, right? Go ahead. Yeah, it goes and talks to the operating system for us and says, I need some memory. I need some land to put this new object because we're about to, she pointed out, we're about to build an instance of an object and I need a place to put it. All right, so that's the new keyword's job, is to go get us memory. So that means that a constructor will always boil down to, as he pointed out, a memory address 100% of the time. So newer languages, Java, C#, Swift, don't require us to have return types for our constructors because the return type is always a memory address. You go to some older languages like the newest version of C++ also doesn't make you do this because C++ has gone through, I don't know, 4 or 5 million iterations over the years, but to make it more and more modern. But you go to a language like Objective-C, which is a really cool language, by the way. I wish iPhone didn't go to Swift. That's a sellout thing. They just tried to compete with the Java people. But that makes you have a return type for a constructor, which might feel a little inconvenient, but it really opens up all this detail that I'm giving you here, right? And it might seem like we're beating a dead horse, but I promise you at some point in your career, you're going to be dealing with something that's going to involve understanding how those languages are put together. And that's going to make these things, something will pop up that'll make some sense. I usually will refer to as it'll let you solve that last 20% of the problems that if you didn't know what was under the hood, you wouldn't be able to fix. Kind of like the car mechanic who can change the oil, change a tire, things like that. But things get too much scarier than that. They're not touching it. Something like that. All right. So new keyword always goes and gets us memory. So constructors don't have a specified return type that we have to type in Java or C# because it's always going to be a memory address. So it just makes that assumption for us. Okay. Also throw out there as a reminder that the name of the constructor in Java and C# must be the same as the name of the class. Case sensitive. So if my class name is driver, the constructor with a capital D, the constructor must also be called driver. Why do you think that is? Go ahead. It is the name of the file, but it's related to what we just said. Go ahead. But we'll have a whole bunch of methods that are in the scope too. We just talked about Java taking our responsibility away from having to put a return type for a constructor, right? So now Java needs to be able to identify our constructors to know whether or not that was a syntax error. Did you forget to put a return type on a method? Or are you cool? Is your syntax okay? But you need to name your constructor the same thing as the class name. So anyway, you cut it, it put a constraint on us, didn't it? You know, you either put a return type that's a pointer, but why is that a problem with Java? No pointers. Well, there are pointers. There's just not a special syntax for pointers. So when we were dealing with C++, we had pointers all over the place. We used that little asterisk dealy, right? Or the ampersand if we wanted to extract the memory address from something. Java's taken those away. Java says, hey, look, we're an automatic transmission here. We'll deal with it. You need to have this, that, or the next thing. We'll treat it as memory when it makes sense to treat it as memory. We'll treat it as a value when it makes sense to treat it as a value. You don't have to worry about it, so we're not going to give you any syntax for doing that. Which means that if we had constructors that required us to put a return type in Java, we don't have a return type to give it. We have no way of saying this is a memory address in Java, even though they exist all over the place. All right, questions about any of that? All right. And then, so the very last thing before we're going to pick up is reminding ourselves about that static versus non-static. So tell me what you know about static versus non-static. Methods or fields is what these relate to, right? What does it mean for a field or a method to be static? Well, they could change.
It cannot be changed by external objects.
That's public-private protected stuff. Yeah, so she's referencing if I had asked the question like, what does it mean for a member, a field or a constructor or a method to be private? That means if you're outside of that class, you can't touch it. You can't. So that's more security things. That's the public-private protected discussion. We'll bump into that again when we're writing stuff. Go ahead. Yeah, I actually like that. So static is owned by the class itself, not an instance of the class. So it does not have access to this keyword. Where this is how an object refers to itself from within itself. Well, if you're inside of a static method, there is no such thing as yourself. You are the class at that point. You're coming from what's called a static context. So anywhere inside of that method body, the keyword this, that pointer to the instance of the class that you're currently working with, is not in scope. It's not available to you because you're not working with an instance of a class. As opposed to non-static members are owned by instances of the class and therefore can only be referenced using an instance of the class and do have access to this keyword. So when would we make a method, for example, static? If you're the one writing the code, obviously we got a whole bunch of classes from Java, from the people who wrote it, Sun Microsystems back then, Oracle now. What would be the rationale that you might say, okay, I'm going to make this method static? Two uppercase. Okay. So right here, we're looking at the character class in Java. Notice that there's a method in here called toUppercase, and it's static. Here we're looking at the string class. These are classes not written by us. These were written by Sun Microsystems, the makers of Java. Here's their toUppercase. Returns a string, because we're working with a string, but it's non-static. We know it's non-static because we don't see the word static there. Why is toUppercase for strings non-static as opposed to toUpperstring for the character class static? Go ahead. Okay. So like with strings, we might want the string hello to become uppercase or the string elephant to become uppercase. We're going to create multiple instances of strings. And when we call toUppercase on a particular instance of a string, we want it to convert that particular string. to uppercase. Okay, makes sense, right? We want strings to have their own individual abilities that know a lot about that particular instance, namely what string does it hold. What about the character class? Why is the character class a static method? Similarly, why does it require you pass it something? You probably actually will like this version of it better. Why does it require that I give it a char? What do you think? Let's start with requiring it to give it a char. Forget about the rest of the rationale. I did not have to give the non-static method to uppercase in the string class a string. Why didn't I have to give it a string?
Because you're calling it using this or using this.
Yeah, you're calling it using an instance of the string class, so it already knows about the string. That value is stored inside that particular instance. Whereas in this non-static version of to uppercase for the character class, I have to give it the character. Because how do we call static methods? We don't use the instance name. What do we use? Name of the class. So in this case, I would say character dot to uppercase. Now, if I didn't give it any inputs, what character am I asking it to convert to uppercase? Character is the name of a class. Character with a capital C. It's the name of a class, not an instance of a class that we've shoved a value into, right? So if I say character dot to uppercase, it does not know what character I want to convert to uppercase. I got to give it to it. That's why this guy takes in a char. Okay, so that's that side of things. That's why this takes in a value where the other one didn't have to take in a value because the other one already had all the information it needed. That isn't to say that all instance methods have no parameters. It just doesn't need the stuff that's stored inside the instance already. You might have to give it some additional information as inputs. In this case, it had everything it needed already. But why do you think that folks at Sun Microsystems chose to make to uppercase static? Why do you think the people who wrote the character class, so the folks from Sun Microsystems, later purchased by Oracle, whatever, why did they choose to make a method inside of to uppercase a static method instead of a non-static method? Why didn't they just make you create an instance of a character? Character C equals new character, maybe it's a lowercase a, something like that. Why didn't they make you do that in order to convert a char to uppercase? Why do you think they made that decision? Good. You probably do actually end up saving on memory. I doubt that was their real rationale for it, but you certainly are not storing the same value more than once. So there's probably truth to that. So if we extrapolate that a little farther, we would say, well, there's already a way of storing chars inside of Java, right? Inside of the char primitive type. We already have the ability to hold a char. But since that's in a primitive type, they don't have any other abilities. All they can do is hold a value. So if we want to be able to do things to those kinds of values, we need to have an external object that can operate on those values, right? Well, rather than making you restore the value, they now just gave you basically a factory called character that you can throw chars at, and it will do various things to those chars that you give it. So they created a factory that is a class called character that has in it a static method called to uppercase that knows nothing about what you might want to convert to uppercase. Instead, you have to toss it. Kind of think about this like a toaster. You got to put the bread into the toaster, push the button, and then a couple minutes later, you'll have your piece of toast. A couple minutes later, a couple microseconds later, you'll have your uppercase version of the char you gave it. All right, make some sense? This is a language design decision, but it's based on a logical pathway. Realistically, most modern programming languages, including current version of Java, if I go up here, based on the conversation we just had, you might wonder, let's see, where's my constructors? You might wonder, why is there a constructor for the character class that allows me to build a character given a char when this guy's filled up with a whole bunch of static methods, except for the one that gives you the char value. Why do you think they gave us a constructor for the character class, even though what I'm advertising to you is, as a programmer, you will probably never use that or rarely use that. You would always just create a char, and if you needed to do stuff to the chars, you would say character dot whatever you wanted to do to it and pass it that char. Why is there a constructor, do you think? Go ahead. Okay, so I think it's the correct rationale, but really the decision was made for us by the language designers. They've designed the language fully around objects. So in order for, so basically the modern primitive types are backfilled by objects. So a char in Java actually is a character object. An int in Java actually is an integer object. When you reference them as chars, if I have char c equals a lowercase a, and then I say c dot something, it treats that as a primitive type and says, no, you can't do stuff with primitive types. But under the hood, it's kind of like our new types of cars that, old cars, if you have parents that are mechanics or something like that, they're always up there fixing cars. They can work on older cars that aren't filled with computers, some of that. But if you have a newer kind of car where, you take it in the mechanic, they have to hook $1 million computer up to it to tell you what's going on. You can't really work on those cars yourself very easily. So it's kind of like this is the newfangled kind of car where under the hood, it's creating objects and things like that. It's doing things the way it's most efficient for the language, but the programmer themselves don't really have access to some of those features. Right? So this exists for that to exist, even though you technically could create an instance of a character class yourself if you wanted to, because you do have access to the constructor. And remember the hierarchy for objects in all object-oriented languages. So here we have the character class has exactly one parent, which is object. So when we click on object, we see that every single object that exists inside of the Java language has these abilities. All right. One of those abilities is something called clone. Anybody remember why that clone function works? So first of all, we see that it is a non-static method, right? We don't see the word static there. We see that it's protected. So as she pointed out earlier, we have this other kind of security thing, public, private, protected. They made this guy protected. What does protected mean? It can be called by anything inside the object class or children of that class. Okay, so public means everybody can call it. Private means you can only call it if you're inside the object class. Protected means if you're in the object class or you're one of the children of the object class, which is synonymous with saying if you're an object in Java, you are a child of the object class. That's how the language is built. You have access to this clone function. So this clone function creates and returns a copy of this object, which ultimately means it creates if you have an object with whatever it's filled with, it creates a new place in memory and copies everything from that object into this new place in memory so that that object technically exists 2 times now. Why do you think that exists for objects? Remind me, what's the difference between pass by value and pass by reference?
Value creates a copy, sends the copy, type by reference, sends the memory address.
Okay. So when you're calling a function method, and you are passing by value, all primitive types by default are passed by value. It is sending in a copy of that value, which means any changes you make to that value inside of the function will not be permanent. They're only felt inside the function. Once the function ends, that value that you passed in reverts back to its original value because a copy was sent in. If you're passing by reference, means you're getting a pointer to that value. In C++, we had to specify we were passing in the pointer to it, right? We had that special syntax for doing it. In Java, we don't have that syntax. We don't have that ability. Java decides when we're passing in by value versus passing in by reference. So all primitive types are passed in by value, as well as strings. Strings bridge the gap. They're in both gangs. All object types other than strings in Java are passed by reference. And when something's passed by reference, you're giving it the real memory address where that real object lives. So any changes you make inside your function will be permanent changes. Make sense? All right, so it's kind of like me giving you the address of my house and you going and spray painting my garage. When I get home, I'm going to be in for a surprise. Okay, because you went to the real house and the real garage and you had the real can of spray paint. So when we talk about pass by value and pass by reference, and then we get back to, I was dealing with it in this, the clone. Clone is our way in Java of passing an object by value. Because effectively, the reason you would maybe want to pass something by value is two reasons. One reason is because you want the value not to be changed externally. You want anything that happens to the value inside of that function to not impact the value of that variable outside the function. So that's one reason you might do it if you had the choice. As I'm saying, Java is going to choose for you, but this is the rationale for it. Okay. The other reason, the driving force, is typically dealing with memory at some level, where typically if something is relatively small, passing it by value is okay. So like an int is 32 bits, right? A memory address in most modern operating systems are 48 bits, up to 64 bits, but they use 48 bits for user space. You'll learn about this in operating systems. All right. So even if we say 64, 32 bits is less than 64 bits, right? So we would say that passing an integer is actually lighter, more memory efficient than passing a pointer. So if I pass an integer by value, it weighs 32 bits versus passing an integer by address, which now weighs 64 bits. So the rationale for why something might get passed by reference has to do with memory efficiency to a certain extent. But now, is there that big of a difference, especially by modern standards of memory, between 32 bits and 64 bits? Or are both of those values pretty small little containers of memory that you're probably not going to miss, right? Whereas you might have an object that has 800 fields in it and 300 methods, and just imagine the scariest object that exists. That guy might weigh gigabits, lots and lots and lots of bits, right? Might be very heavy, very memory inefficient, where you probably wouldn't pass somebody that entire thing. Just like if you're having a party, you wouldn't hand me your house and tell me to open the door at 8. You would give me the address where I can find your house, passing it by reference. All right. So if I had something that was going to automatically get passed by reference in Java, which is every single object except strings, and I intended to make some changes to that object temporarily inside of that function, I could either pass the clone of an object to that function, so I'm working with memory that I don't intend to use again, or the function could internally clone the parameter that was passed in and work off the clone so that the original is not impacted. So this clone function just duplicates the memory for an object in a separate bucket of memory. So it makes it as if it'll behave for you as if it was passed by value. Not commonly used, but that's the rationale for why that exists. There's notify stuff we're going to be talking about pretty soon when we talk about threads. ToString. Anybody remember the reason that all objects have a toString method? let's see. Did we write toString for this guy? No, good. All right. So I'm going to just comment out some of the stuff. We're going back to where we ended last semester. And I'm going to have to remind myself of all that anyways. So comment that out. All right. So right now I'm just creating a couple of instances of this object called player that we invented last semester. Doesn't matter what it does. It's an object. All right. So now if I say system.out.println P1, let me do this. Is that font big enough for everybody? All right. What's going to print out right here? Okay. Let's go ahead and run it. And we get, I believe if I didn't see toString in there, we'll see a memory address. Okay, so this is a memory addressy thing, right? This is how Java formats its memory addresses because Java technically runs inside of what's called a virtual machine. It's a machine written in software, so it's running as an application on top of, in this case, Mac OS. But its memory address is this unique hexadecimal value, which is 1, 2, 3, 4, 5, 6, 7, 8. 8 times 4, 32 bits, 32-bit address. All right. So go ahead. Oh, thank you. So let me just finish this thought. All right. So if I had put toString inside the player class, and I had this guy return woot, and then I run this again. Oh, capital S for strings. Now we see woot pop out of there. That's the purpose for that toString method inside of objects. So that system.out.println and any other object that might be interested in can get the string version of this object. And the default behavior of that is the memory address. But you could make it, in this case, I said woot, or I could have made it the name of the player like she had mentioned that maybe it'll say Mike. All right. So no homework. Expect to have some homework over the weekend, though. So I'll see everybody on Friday.